Okay, we got screen share and we are recording. I am obviously starting a little bit early, and I don't think I'll have anybody join me. I've sent announcements out to everybody and about the due date. Okay, that's been changed for XLS 4 and 5, and for the Stephen Few Chapter 5, that exam. Notice also I posted this, I believe, if I'm not mistaken, a message as well, and then no physical class session today. The ice storm, and of course the school's closed down, so if you're going to probably be viewing this Friday, maybe Saturday, but that's why I set these back to Monday the 26th. And really part of this is, XLS 4 and 5 should already be uploaded. We've worked those cases through, and really all you ought to have to do, if you haven't already, is do the Chapter 5 exam. Then, of course, we'll start over next Tuesday. Now, as I've noted, we've been working ahead, okay? And I've done that for a couple of reasons. One of them is these kinds of situations, okay? And the other is when we get the access that we will find that you're going to find that you probably, we may have to go a little bit slower because so many people don't have the experience with it maybe that they should. Now, also don't forget, I've got a recording for you that was back from Virtual Tuesday. Okay, so that's the story. That's what we've got going on here. Now, we're going to take a look today at case number 9. This is a spreadsheet case number 9. It's over there in the it's Karma Digital, and if you you should have a if you join me today, which I don't think I'll have anybody join me, or if you take a look at the post, okay, and the recording, you're going to find that you'll want to have the book with you. You're really going to need it. You really need to have it with you as we go through this. Okay. Now, I want to take a few minutes, and I talked some, I believe, Tuesday about the XY relationship, and again, this situation where we look at two factors or variables to see if they are related. And the textbook talks about there at page 82, talks about, and then 82, it talks about about regression analysis. And regression analysis is simply a process whereby we take a set of data, okay, and then we create what's known as a line of best fit, okay, and then we see how things are scattered around it. Now, before we go in and look at the files, okay, I want to show you a couple of things. And there's, let's see, there it is. And here's an excellent picture of, I'm going to download this. It's a text file, and it has a link to a New York Times article that takes a look at mass shootings versus gun ownership. And I'm going to go ahead and pop that in there, okay? Now, I'm not making any statements about guns or policy or anything like that. I'm talking about how things get analyzed. I want to show you, okay, if you look, and this is extremely well done. It's an excellent article. Notice that we have a scattergram, basically. And what they have up here, okay, is on the y-axis, okay, they have the number of mass shooters, okay, and then over here on the horizontal axis, we have the number of guns. And as they note here, these data are 6 years old now, of course. And you know, and let me say it again, I'm not arguing one way or the other, all right? I'm showing you a way that, you know, we take data and put it into a scatter diagram. And in fact, as you go through this article, it's an excellent article. Here's another one, okay, where they look at mass shooters per million people. So what they've done here now, and now you start to see some separation, okay, and this is guns per 100 people, and then mass shooters per 100 million people. And this is, as you mentioned, as I mentioned before, we use ratios, okay, to clean up data, and that gives us a lot better picture. And you know, places like Yemen and Afghanistan, Iraq, I think you'd understand why they have a high number of guns. But now, and it's interesting to me because here's the United States, of course, you know, and this washes out scale, okay, and uses, and we see that word per, we're talking about a ratio. But interestingly, France and Canada, okay, I think it's just fascinating. And so again, a very well done scatter plot, okay. Now, I think there's a third one here, and I want you to notice, and it would be worth your while to get that text file, come over and read the article. This is one of the best articles for just the general public I've ever seen that uses correlation, uses a scatter plot or the notion of correlation, okay, correlation. One of the best I've ever seen. They talk about mental health, spending rate for that, okay, and they'd have some links to some other things, and they talk about beyond the statistics, okay. And so you would want, I hope you'll take a look at it, because again, I'm not advocating a position. What I am doing here, okay, is I'm quite simply saying here is an excellent presentation, all right, using a scattergram technique. Now, I'm gonna close this off, okay, all right, and we'll get that fixed up. Now, I'm going to open a new tab, all right, and I'm going to do a search for educational attainment. Educational attainment. I'm just going to call it educational level versus earnings. And this is a topic that ought to be, you know, near and dear to your heart. Now, let's start. Here's something about unemployment rates. And I want you to take a look at this because, you know, we don't always have to use a scatter diagram to compare things, okay? But this is a nicely done set of bar charts. And notice how they are almost the exact mirror opposite, okay? And what they're basically saying is that the more education you have, okay, the less likely you are to be unemployed, and that's the blue, okay. And you see they give you a total or a mean, and that's that line. And then over here in the green bar, they show you median usual weekly earnings. And the average for all workers in the United States is $885 a week. So you're talking 40,000 some odd dollars a year. Now, again, you know, if we did the scatter plot, we'd see that. Now, I'm going to go back over here and I'm going to click on images, because there are some excellent images out here. And I want to find the one you can see. Again, we looked at these. Okay, we can use bar charts, but sometimes it's just simply more effective to use a scatter plot. All right, and here's an interesting here's a scatter plot for you. Okay, per capita income versus education. Okay, and there they've washed the data to see how they look. Here's another, you remember I talked about that line of best fit. Here we are. And notice we have all these data points. And one of the things we're going to do in this case is use a regression, the regression equation to regression analysis to find out how much the scatter or how closely these data hug that line, okay? Because the line would show a perfect correlation, and you'll see that. Here's another one, quite good. GDP per capita, okay? And so we'll take a look, and I'll go through a couple. There's one other, it was educational attainment. I want to find it here if I can, because it's a nice little chart that really shows you those differences. And bear with me here for a moment. I probably should have just saved it, but I didn't. Okay. And thank you for being patient. I'm going to see if I can find it. And here's another scatter plot. You can see median income and college education by country. And you can see here's the median income. This y-axis is also known as the dependent variable. It's the variable of interest, the thing I measured. And then down here is what we would call the independent variable that we just use to look at categories or parts. Now, wow, I wanted to find that for you. And because here we go. This will help you out. This is an XY chart that compares your birth year, okay, versus your income achievement, okay. So you're going to see this as we work through this today, that we can use this idea of correlation, or how much things relate or occur together out in time. Now, we're going to assume, and we do assume, that in this case today, Karma Digital, that we're going to look at a quality control program, and we're going to compare the percentage of defective items with the amount of stuff we produce, okay? And then we're going to use the regression equation, all right, to analyze that and to see how valid those comparisons are. Because look, let me go back to that. Well, let me go back here to the gun thing for a moment, okay? Now look, notice we have, the mass shooters versus the number of guns, and that becomes a scale issue. The United States has a lot more people than the Philippines, and we're pretty close to some of these other countries down here. But the point is this: you can't just simply say because we have more guns in the United States that we're going to have more mass shootings. That's a factor, and there's a high correlation between the two of them. And there's no doubt about it, okay? That's why you have this outlier over here. But that's just a piece of that whole puzzle, okay? There are a variety of factors that come into play, okay? So as all of you are listening, and you're young people, to this national debate, remember, it's a lot more complicated than it seems. And probably if we did all these different things people tried, we might not stop it, but we would probably mitigate it. Because this is like the story of the blind people who had an elephant in the room, and one grabbed the trunk and said, I have a giant snake. You've heard that story. So we have these things called intervening variables. But we want to use a tool like this to help us understand how much things correlate. Now, the beauty of a regression analysis is that it not only lets us compare two variables, okay, compare a dependent variable and an independent variable, it also lets us look at or measure the extent to which any variation between the two of them, okay, how much that comparison explains for the variation in the data. Okay, and again, you'll hear people use the term outlier. Well, here's an outlier. But see, now again, just like we did with the accounting ratios, let's take a look. You remember we talked about the accounting ratios and how we use ratios to wash data to get everybody back to an even scale. All right, and another way to do that is with logarithms, natural logarithms. Here we've used scale, mass shootings per. So that would be the number of mass shootings divided by 100 million people. And then we have the number of guns divided by 100 people. So we have these ratios, and now it presents a whole different picture. Okay, in this first scatter diagram up here, the Yemen is nowhere to be found. But now we come down, and here they are, because we cleaned the data, and you start to see how these have this. These are not as all bunched up or clustered like they were, and the reason is that by applying the ratio, we cleaned up the issue of scale. Okay, so we'll talk about that some more, but I wanted to show you these so you can see this is a tool that we can use. So we're going to use the Microsoft regression analysis. Now, I'm going to close off this extra tab. And again, let me say this. I'm not advocating a particular position or policy, all right? That's going to be for you to decide, all right? But I wanted to show you a way that people analyze two variables. And you need to be paying attention, because you're going to get a hands-on problem in exam number 2, if I'm not mistaken, or 1, where you're going to have to think you're going to have to take two sets of data, okay, and do this do this type of analysis, okay. Now let's and in business, let me say this. In business, some business examples would be the interest rates versus housing starts. When interest rates are up, housing starts are down. When interest rates are down, housing starts are up. When interest rates are high, the value of stocks diminish. Common stock, the shares that are traded, go down in value because it costs companies more money to operate. And when it costs them more money to operate, it eats into their profits. And also their ability, for example, to pay dividends. Okay? And it's just the opposite effect when interest rates go down. Okay? So we've got a good, we have a good, a nice, easy way to take a look at this. And really, for you as a business person, you're always looking for those factors and trying to see, okay, how do these two things kind of work? Well, I want to show you a finished product, okay? And then we'll start to work on it and build this. This is one that I did. This is one I did yesterday, and I'm going to download it. It's called Excel Case 9 Harmon. And this is where we took the Karma Digital information, and we did some work with reformatting and retitling, and then we ran the regression function in Excel, and then we did a little work with it. And so we're going to do some more, okay? Now, I've got that there, so something should happen today. You always have, and I'd like you to try to work along with me, but if you can't, you've got this that you can upload for XLS 9. So I'm going to close this off. Now we're going to go over here to the Solve It student files, okay? I'll go down here and find those. Solve It 6.0 student files, and we're going to download that. All right. And I'm going to get Karma Digital, that Excel file. That's case 9. Okay. And I'm going to enable the editing. And I'm going to click File and then Save As. And I'm going to put it on my desktop. And I'm going to call it Excel case 9. And I'm going to put Harmon. And I'm even going to put February 22, 2018. Okay, so I'm going to save this file down on my desktop. Now, what I'm trying to do, remember, I'm going to do this every time so that you don't end up creating a system file that I can't open up or you can't open up. So we've got it saved. Now let's close that Excel file. Okay, and go back down to your desktop and let's find it. And here we are. This is Excel case 9, Harmon, February 22. All right, and let's open it up. And we're going to do some work here. Okay, now if you take a look at the textbook, and again, as I've said before, every one of these cases, it starts off with some information about the company, and this company makes DVDs. Okay, and they're a DVD replicating company. So somebody sends them a movie on a DVD or music player, they replicate it. So this process of replicating it. And they just get, and I'm over on page 81, okay? And what's happened is that they're having an increase in the percent defective. Now, I want to show you a process that I think you'd be smart to go through, and it's basically this. The first thing I'm going to do is eyeball the data and see if, just without even doing a chart or anything, if I can, without doing a chart or anything, if I can identify a pattern. Now, look, when it becomes a whole bunch of cases, several hundred cases or 1,000 or something like that, that's a whole different matter. Okay, a whole different issue. And so we're just going to look at it, and if I look at the data, I just kind of eyeball it. I have few enough cases here to see when I look at 1999 versus 2008. It's obvious that we're producing more every year. And when we look over here, we see that the percent defective is slowly increasing. Okay, and let's look at this for just a moment. And I'm just going to, this will be equal C11 minus B11 C11 minus C10, and that's 4. Now let's see if we can just go ahead and come on down with it. Yeah. Now here's what's happening. Every year, the percent defective is going up, is increasing. Here's 4/10 of a percent. This is 0.8 of a percent. Okay, remember these are percents. So what we're really looking at here is 0.015. We just took a shortcut. So it's gradual, but the percent defective is going up. Okay, now I'm going to click on cell number C, all right, and in front of the word percent, I'm going to add actual percent defective, and this will make some sense to you here in a little bit when we're through. Okay, now I'm going to format that to be in the middle, just like I'm going to do that with the production volume. All right, now this annual percent defective, I'm going to scroll down here from 10, cell C10 to C19. Now I'm going to put them in the middle. It just looks nicer. All right, and now they want us to add the regression line, okay? And that regression line will be a forecast. Okay? And I'm gonna, let's see, I'm gonna wrap that text and then nudge it out enough to make it look nice, okay? And that's a forecast. All right, now over here in the tasks, here's what they ask you to, they want you to do the analysis tool pack, all right? And then they want you to add a header, okay, which shows you the predictions if we use the regression line. So yeah, and that's right in the middle, page 83. So we put regression line, and I put in parentheses a forecast. Okay, so far so good. All right, now before we do the regression, let's just do some simplistic analysis. I'm going to take my cursor and I'm going to put it on B10, and I'm going to come all the way down to B19. And I'm going to come over to our old friend conditional formatting, and I'm going to use data bars gradient. And just to be, I'm going to put it in green. And then on the actual percent defective, I'm going to highlight cell C10 to C19. And I'm going to do conditional formatting with data bars, and I'm going to do a gold gradient fill. Okay. Now, first of all, I have the school colors of OBU. That's cool. But more importantly, here we've done basically a really quick and dirty bar chart, and we can look at direction. And as you can see, the production volume is sloping upwards, as is the actual percent defective. So just on the face of it, I can see that it's going up. You know, just a while ago, we looked at what we call the residuals, okay, and that was, we looked at the change year by year in the percent defective. Well, when we do the regression line, we're going to create a thing called the residuals, where we take the regression line. And the regression line is based on the equation for a straight line. Okay, and we see these are trending upwards. Now I'm going to go ahead and get rid of that conditional formatting. So, and so far I see these two do appear to increase together. Now listen, it's always important, clear rule from the selected cells, it's always important to understand that, just because two things correlate, it doesn't mean that there's a causal relationship between them. Okay? And selected cells. Back at the turn of the 20th century, sociologists and psychologists, they got correlation coefficient and how to do it. Okay, and so they begin to compute the correlation between the size of a person's head and whether or not they'd be a criminal, or the amount of space between their eyes, crazy stuff, and which had nothing really to do. And of course, they'd also see if there was a relationship between the size of your head, okay, and your IQ, which is about the stupid. But when people have a tool, sometimes they get a little over enthusiastic with it. So you always want to be making sure that you select the right tool, and you want to make sure, okay, that you have some way to say these two variables that I'm comparing have something to do with each other. Okay. So we've got some data to work with here. We've done a very simple little, we did the conditional format to produce some bar charts, okay? And yeah, they're both trending upwards. So let's do one final thing, okay? And I'm going to click Insert, and I'm going to click Scatter. I'm going to do a scattergram, and I'm going to select my data. And I'm going to add, the series name will be series name will be percent defective versus production volume. Okay. And then they say, what are the series X values? And these are and the book talks about that. The X values are the dependent variables, independent variable, and that's going to be production volume. Okay. And then the series Y value, also known as the dependent variable or the variable of measure or the variable of interest, is going to be the actual percent defective. And I'm going to click OK. Okay. And I have a quick and dirty diagram. Now, if I want to, I can come over here and edit these. I think they'll let me edit them. Okay, I'm going to click OK. And here we have the percent. And notice we have our scattergram. Now, I'm just going to click right here, and I'm going to put Add Trend Line. And we're going to say it's a linear trend line, and I'm going to close this. I'll set the intercept equals 0. Okay, and I'm going to close it. And there's that line of best fit. And so what we try to do is to see the extent to which the intercept, that is the coordinates in this Cartesian plane, interact with each other, how closely they hug this line of best fit, or how far away. Now here's an outlier here, and here's one that rides right in. So we've just done a quick and dirty look at these, and now we're going to be ready, okay, to go ahead and we'll cut this, and we're going to use the regression equation. All right. Now, in order to do that, you have to make sure that you have the data tool pack in Excel. So if it's your machine at home, your laptop or your tablet, or if you're using a computer at the lab, you're going to have the data analysis tool pack on Excel. And so I'm going to show you how you do that. You click on File, then you come down to Options, and then you go to Add-ins. And when you look at the add-in dialog box, if something is active, it's up here in the active application add-ins. If it's inactive, i.e. you're not using it, it's going to be down here. Now, I'm not using the Analysis Tool Pack VBA, so I'm going to click that and then click Go, and I'll get the add-ins box, and here I chose the Analysis Tool Pack. I also have the Euro Currency Tools and the Solver add-in, and I'll click OK, and we're good. Now, to make sure that you have it, click on the Data tab, and if you come all the way over here, you're going to see in the Analysis box, Data Analysis, and click on that for a minute, and this will show you all of the tools, statistical tools that are here in Excel. Let me say this: Excel is there's another product out there. It's called SPSS. SAS also makes its own statistical tools. they are maybe better than Excel, but not much, okay? If we're counting accuracy out to 300 digits to the right of the decimal point, 900, 597 and versus 594, yeah, I'm not going to worry about it that much. So, we can use Excel tools. And so we have the data analysis tools, we have those loaded in, we're ready to go. Okay, now here we're going to go ahead and do this, and I'm going to take my cursor, all right, and I'm going to start at, and I'm going to start with B9, okay, and I'm going to scroll all the way down here to C19. And I'm going to click data analysis, and then I'm going to find the regression equation. I'll click regression, I'm click OK. Now, let's look at this. First of all, okay, I want to make sure that I click labels, because I have labels. Then I want a confidence level, and typically that's about 95%. We'll click that, okay? And we want to choose the Y range. So I'm going to do this, and the Y range is the actual percent defective, because again, that's the dependent variable or the variable of interest. Then I want the input for the X range, which is the independent variable. And now I'm also going to click on output range, and I'm going to choose right here at J5. And I'm going to come down here and put, I want the residuals. And I want the line fit plots. And I'm going to click OK. And I'm going to get my output from Excel. Look, as somebody who learned statistics, doing this stuff by hand, maybe with a calculator, okay, you have no idea how lucky you are to just plug in the data and let the machine do that work. Okay, now I'm going to go ahead and make this a little more visually easy to see. So I'm going to come down here to the regression statistics. All right, and I'm going to go back up to home, and I'm going to make those bold, and I'm even going to make them a little bit bigger. And then I'll move it around so I can see what I'm looking at. Okay, I'm going to come down here where it says ANOVA. I'm going to do the same thing there. Make it bold. Maybe make it 12. And I'm going to come down here to this showing us the coefficient and the intercept. Okay, and I'm going to make that bold, and I'm going to size it up to 12. Okay, and made a little bit of a mistake there, because instead of okay, I want the intercept and then the production volume. So what I should have done, I'm just going to back out of this. I don't like what I've got here. Okay, I'll just, okay, and I'm going to take this here, and I'm going to delete it right here as well, and delete this stuff. Okay, and I'll delete those, and I'm going to come down here and put no border. I flubbed up there, and I apologize. Sometimes chewing and trying to do this at the same time. Walking and chew gum is hard for me sometimes, isn't it? All right, now I'm going to come over here and do a blank. Now I'm ready. All right, I'm going to click on data. Okay, and I'm going to do the data analysis tool pack, and I'm going to click regression, and I'm going to choose my input X range, which will be and I have labels, and then I'll put in my input, my input Y range will be the percent defective. That's the Y range. And then the X range, that again is the independent variable. I want to include those labels. And I've got the confidence level, output range is at J5, residuals, line fit plots. And let's see. Much better. Good. Now I'm going to come down here, and I'm just going to take my cursor, and I'm going to come over here all the way to R, column R, and then come on down here. And I'll have to do a little bit. I'm going to click. I'm going to make everything bold, and I'm going to make it 12. So I can see it. All right. And I'll squinch this out a little bit. And I'll squinch this out a little bit. Okay. And let's see here. We'll look at that here in just a second. Now, where it's down here with observation, I'm going to go ahead and instead of that, I'm going to put the years. And I'm just going to take this starting here at 1999 and go all the way to 2000. I'm going to copy them. Right here's the observations. So it's clear, that what these are. Now the percent defective. Okay. Now let's talk about the output here. Okay. First of all, and this is important, that we get the summary output. There's a thing called the multiple R. This is the correlation coefficient squared. Pardon me, the multiple R. This is if I use regression, but I work with several factors, okay, I see the extent to which they correlate. Well, I've just done the regression of these two, so there's some other factors in here that I haven't named. Okay, but they're there. Now, to know just about these two, I have the correlation coefficient, or the R squared, the correlation coefficient squared. Okay, and that's the one that's important to me, because that tells me, okay, how much of the variation is accounted for by the comparison of these two variables, production volume and actual percent defective. Okay, and that's what we've got going on. Now we've got the standard error, okay, and that tells us how much does it tend to be off. The adjusted R square is a little more stringent, but we see these two variables are highly related. Okay, so it's we can be for sure now that, having done just some preliminary kinds of looking and now running the statistic, we can be definitely sure there is a pattern, okay, that's been established. The more stuff I make, the higher the percent of defectives. Okay, and they have some in here about the analysis of variance, which is past the scope of this course. But here's a section that's very important, okay, and these are the coefficients. And so I'm gonna go ahead and put some fill around them. so it alerts me. Now you remember the equation for a line is y equals mx plus b, okay, where y is the intercept, okay, and mx is the slope, the rise and the run, okay, and then we have the b is the point. So this says, okay, here's the intercept and here's the production volume, okay? And what we're going to do now is we're going to compute the regression. Now, before we do that, all right, I want to see, there's one other feature from the output over here that we want to take a look at, because this is the best part. Excel will give us a beautiful little scatter plot of the actual percent defective, and the predicted percent defective, okay? And that regression line is that forecast. Now, this is what was actual, this is what was predicted. And again, notice I'm going to click on here and I'm going to add the trend line. And I'm going to do linear, exponential, set the intercept to 0. Now I can mess with this line a bit, and I'm going to format the trend line, line style. I'm going to make it a little bit bigger so it's easier to see. Now, one of the things that you're going to find is sometimes it's worthwhile to go ahead. I'll move that out a little bit. Okay, and now we can see that relationship. Now I'm going to go ahead and resize this a little bit with my cursor. I'll put it on there. And we don't have to do any data callouts or anything like that, because we can just put our cursor there. But the blue is what was actual, and the red is what was predicted. Okay, and so you see we got a couple of outliers there. And because of these high R square and adjusted R square, we have two things that are statistically related, and we know in the real world they are related, because we produce stuff and then we find out how they're defective. Now, before we go any further, I want to do one final thing that will show you why this becomes so important. Come over to cell. I'm going to come here to cell I-10, and I'm going to put equal B10, and I'll make that a $sign, times, and I'm going to make that C10, and I'm going to add a parenthesis, and I'm going to define apartment parenthesis over 100. And I'm just going to scroll all the way on down. All right. And I've got a little bit here. Now I'm going to go ahead and get rid of the zeros. Okay. Now, let me take this formula and I'm going to control copy. And I'll put this right up here. And here it is. Now what I'm doing is I'm taking B10 And of course, the dollar sign in front of the B says stay in this column. And I'm multiplying it times C10. And I put the dollar sign in front of the C, saying, hey, we're going to stay in column C. And I divide that by 100. If you look there, it says it's the actual percent defective. So I just go ahead and take C10 and divide it by 100. And what I actually would be looking at is 0.015. Okay? And then I just drag and drop it on down. Now you can see how this starts to become a very unfriendly scenario for me, because these are the at this level of production, okay, this is what I'm getting. And I'll make sure I've got that right. Yep, that's right. So you can see we begin to, we're producing some significant amount of of junk. All right, and just to be sure, we're good. Is indeed 45. So I haven't made a math error. I'm just checking. These are the number, raw number. I'm gonna put raw number. Okay, I'm gonna put units defective. This puts it in perspective for me. Okay. I'm just doing that for my own now to say, yeah, now we're talking real money. Now let's say, for example, that every time I flub one of these up, I'm trying to get these shift around, they're not obeying me. Okay, every time I get this, all right, I lose $1.09. So I'll make this 1.09, and of an equal. I'll put a dollar sign in front of the E, and then we're times. Now I'm coming up here to F5, and I'm gonna put a dollar sign in front of. Actually, I can just highlight them and then hit F4, and it changes it to an absolute cell reference. So equal E10. So each defective costs me $1.09. And then I'm just gonna, I'm on down. And this is what it costs. I'm leaving a lot of money on the table because I'm allowing a percentage of defectives here. And this is the cost. And I'm just gonna put cost. Okay. And that's, cost per defective. Now the truth is that over 10 years, I'll move it out of it. The truth is that over 10 years, the cost will probably go up. And not only am I losing money here, I'm probably making a lot of people angry with me. Because if I've got some really big customers, and nearly 4.65% 4.6 is almost 5%, which means out of every 100 units, there are 5 that are defective. Out of every 1,000 units, there are 50 that are defective. Pardon me, 20. So yeah, now we're talking real money. This is a concern. So now we want to do the regression line, okay? And we're going to compute that. And they show us how to do that there in the middle of page 43. But before we do that, we're going to go back to our old friend, the name manager. And I'm going to click on this cell right here that has the coefficient for the intercept. And I'm going to click Formulas. And I'm going to define the name. And it's called the intercept. And we're good. Then I'm going to come down here to the production value. Click Define the name. And click OK. Now, you'll also want to make sure that you consider scientific notation. And I would encourage you to go out and take a look and find out what that means. What do we mean when I see that minus 0.07? What's going on there? All right, so we have the coefficients. In fact, I'm going to go ahead and bold them up. And they're bold, okay. And it's a 12. All right, now we're going to do the equation, and they tell us here multiply the value of the x variable 1. That's the production volume, okay, by each value of the independent variable that's pieces produced, or the production volume, and then add the constant, the intercept. So we're going to put this formula, and before I do, I'm just going to go ahead and work over here. I'm going to put, well, we can do it here because we got the name manager. This is going to be, I'll put a parenthesis, equal, and we want, that's going to be the production volume figure. Let's get out of this for just a minute. I messed that up. Equal, and then parenthesis. No wonder it was going wacky. Okay, production volume times, and B10. I'm going to put a dollar sign in front of the B. Close the parenthesis, plus the intercept. So we have the production volume times B10. Okay. And that production volume is that production volume coefficient. You remember, we're doing a straight line. Y, that is the forecast on the regression line, equals mx plus b. B is the intercept, and mx is that coefficient. That looks at the slope of it, the rise and the rise. And I click OK, and then I'll click this, and there we go. And I'm just going to simply carry this all the way and drag and drop it all the way on down. And now we have the regression line, the forecasts. And we'll go ahead, and I'm going to highlight all of this, and we're going to take it down to decrease it down to 2 decimals. And then we're going to put it over here in the middle. And so we can see this is the actual percent defective. This is the regression line, the forecast. We have that depicted graphically over here. Okay, now on this trend line, I want to go ahead and format the trend line. I also want to make sure I display the equation on the chart and the R-squared. Now, we've talked about the R-squared before. So now that we've run this regression plot, okay, notice that the R-squared is 0.7447. It's a little bit lower than the R-squared that's over here on just the simple statistics. But this is evaluating it now versus this line of best fit. Now, if I really want to see it in its most glorious, it's simple. I just take it and, I'll take this thing and size it up. Well, I think I will. Well, it's getting weird with me. Okay. Now, here's the forecast. As you can see, the forecast is never perfect. That's why we have this area down here called the residuals. And I'm going to come down here over to this K29 and here under the percent defective. Well, I'm just going to click up here and put copy format painter, and I'm going to paint that format. Okay. And the residuals, I'm going to get them down to. Now let's notice here on the end, here's the actual percent defective was 1.5, but we predicted 1.88. And so we were off 0.38. And the residual says, okay, we're high. And again, we're high again because we are at this time we're at 6%. And then we look at that 240, that 3.1 versus the, in 2002, the actual percentage is above us. Same thing for 203, and then again, then we start to see this trend itself out. So I can use, okay, some color. I can use some conditional formatting to see what this looks like, and I'm going to do that. And I'll use some color schemes. I think I'll use this one. And see which one's going to work the best. We'll try this one. Now, what we're seeing is that the regression analysis tends to be above, okay, the actual forecast. And you can see this, the actual is 1.5, but we forecasted 1.8, 1.88, 1.9, and that's what that residual tells you there. And we get concerned about the residuals for a very simple reason. This tells us the extent to which, how far off the prediction is from the actual. And that's, again, is depicted over here in the line of best fit. Okay, this production line plot. So it's very evident now that we can say for sure, okay, we've got something going on. Now, in the text, the authors say, let's add 2 years, so it'd be a 2009, okay, and then a 2010. And I'm going to put those in the middle. And they say the production volume 2009 will go to 15 million. Okay, and then the production volume in 2010 will be 20 million. And here's where the tool really shines. First of all, it gives us some good historical perspective. And it says, you know, while they're not perfectly matched, about 75% of the time, these two are very, very close. And you can see how they hug that line. the red and the blue. We have an outlier here, we have an outlier here. So there is a relationship there. Now, I'm going to be able to make a prediction. All right, so I'm going to simply do this. I'm going to put my cursor there and just simply drag and drop it on down. Okay, and now I have the prediction, okay, for 2009 and the prediction for 2010. This is in terms of the number of, the percent defective. Now you notice there's nothing in here because this is actual. This is a forecast. And so you can see when we jump, we make a jump from 13 million, 12,000 to 15 million. So we go up about a 0.5 on the regression line. Okay. Then when we jump to 20 million, we go off the charts. That's nearly a 2% change. So the tool is a warning for us that we need to handle this. Okay, and this ought to tell us over here as well the units defective and the cost while we're looking at. And it's pretty simple. I can just I can come down here and say, okay, I don't have the actual units, but I can get the units defective easily by taking in fact, I'll see if I can do that. Take that. Yeah. Well, we don't have the actual percent defective. So let's call this is 5%. So here we're talking 1/20th, which would be out of 50 million is going to be 75,000. And we can just do this quite easily. Be 20 times, and that's going to be over 100. And that's 73,000 units. Much more than that. Pardon me. Yeah, I'll get my head straight on here in just a minute. The dollar sign there. And we'll take, and that's going to be time. I'm just going to make it simple on myself. Times 0.049. And that's 735,000 units. And at $1.09, it's real money. So we've established that yes, there's a relationship. Now the whole point of this was to let us see this tool and to understand about how variables relate to each other, okay, and how we can track them and we can make forecasts, okay. And notice the more we produce, the higher that gets. It jumps, okay. And so we know we have an issue that we have to deal with. Okay? Now, we're going to finish this thing off and we're going to make it look, so we're going to make this look pretty, just this data right here. Well, we'll just take the whole thing. Oh, first of all, let's come up here to from A9 to F9. Let's go ahead and put in a nice blue border. There we go. Same thing over here. So we see that we have our data table. And if we want, we can come in here and put, add all borders. And that looks nice. If we want to make sure we don't mess up, that we understand forecast, I'm just going to put TBD. And you say, Dr. Harmon, if I was doing this at work, could I keep this worksheet and then as those data come in, do the projection? Absolutely. And I'll put TBD here. Means to be determined because, we just don't know yet. But we use the prediction. And, if the percentage, when we see that percentage jump there between 2009 and 2010, that ought to scare us. And since these are to be determined, I'm going to bold that. Okay. And you can see, it doesn't look good based upon doing nothing. Now, the quality control part of this, we'd start to have to look at processes, and we'd look at materials and how we're using them. Okay, and so that becomes a process where we do some problem solving and try to figure out what's causing the defects. All right, and that really is, that would be a whole nother course on quality assurance and control. But you don't have to be a genius or a quality control expert to look at this and go, "Whoo, ain't good, ain't good, ain't good, my friend. Not good at all." Okay. So we look at this, and again we use the tool. We have a nice table that shows us some data, and we messed with that a little bit, and we just kind of eyeballed the data. Then we ran our regression analysis, and we did a production line fit plot. All right, and away we go. Okay, and that's case number 9, Karma Digital, where we use the regression line to figure out or to build a forecast that helps us understand where things are headed if we continue to follow suit. Okay, and we didn't know that. Now, I would say this, looking at, if I know if I have okay, you say, is there any way I could try to predict? I've got the prediction here. Is there any way I could also put in an annual percent defective? Well, what I could do would be to say, okay, what's the residual, and I'm just going to pick the equal average, and I'll come down here. And it works itself out. Well, it works itself out to 0. Okay. Now, if I make these all absolute numbers, that's a different story. So I'm going to put, let's try this equal. Okay, absolute. And we'll try this. If that does it for us. Well, we want to get the this is easy. Let's see. We wanted that. I'm just going to do this. I'll just go ahead and make that. I don't have that many values here, so it's pretty easy to do this. And this will give me the absolute value for these. Because the variations go back to 0. That's why we call this, we have a term called regression mean. Now we could have multiplied, we could have squared each one of those to get our absolute values as opposed to the negative and positive numbers. Okay, now we go down here and we'll get the auto sum, and then we'll get the because we want to see how much these typically vary, excuse me. And they vary about 0.26. And so we can see here that would be probably about a 4.86, and then another 0.26 added to that. So a little bit of extra work we can do, but we have our predictions. Okay. The key to all of this is understanding the variables we're working with. Now, it doesn't take if you have defective parts or defective processes of making something, the more you make, the more junk you'll produce. So at that level, this is an easy case to understand. Okay. And the truth is, you might go through this type of analysis on a number of items looking for the key piece of data, and it's going to be this, the R-square, which explains, okay, the amount of variation in the data. And I can account for, and I've got the adjusted R-square here is 0.88. This is before, I did the align best fit. But it's high enough that I know there's a relationship between the two of them. Okay, and so we've been introduced to the stat pack. We've talked about correlation and regression and versus causation. We've taken these data, we've forecasted a regression line. Okay, and we've looked at the output for regression statistics. We went out and we saw some examples of using just a simple scatter diagram that can tell us some things about the relationship between two variables. And so we've gotten that accomplished, and we've seen how to add add the data analysis tool pack. So we're good to go. Okay. Now I'm going to save this file. Okay. And I'm going to close it off. All right. And I'm going to go up here and I'm going to add it into the files. So if you say, what should I upload for XLS9 when it's time, you can upload this. Okay, and let me see if I can find it here. There it is, XL case 9 Harmon. Let's see if it's going to play nice with me. And I had the same problem yesterday that it wouldn't record and it wouldn't upload, and I don't get that. However, remember, I have this Excel case 9 Harmon. You could also upload it, or you could try to work on case number 9 on your own. Okay, well, I'm going to save this. I'm going to stop this and then process it and post the video at YouTube. Okay, and so you can come in and look at it when it works for you. I want to go back over for just a minute and talk about assignments due, because I know we've had all kinds of bad weather. All right. Now, because of the bad weather, I moved these back to the 26th. Few chapter text, that chapter 5 quiz over the Stephen Few text, I moved it back to Monday. Okay, and I sent I put it in announcements, and I sent everybody a message, so there's no surprises there. Now, XLS4 and XLS5 are also due Monday, but you already should have uploaded them as we've been going along, okay? And then on March 1st, we're going to have exam 1. So next Tuesday, I'll talk about the exam and what's over there. But you'd be wise to go there and see the example and then look at the instructions, because it's going to have a hands-on part as well as an objective exam part. And also note, XLS6 is there. It will be due, and we've already worked on it, as well as 7. Okay, folks, stay safe out there, and I'm going to stop the share and stop the recording.